Determine whether the given sequence is arithmetic or geometric. Let's start by taking a look at this given sequence. Let's see if we can figure out if it's arithmetic or geometric. First, let's see if it's geometric. A sequence that is geometric has a common ratio. So here, we need to first test and see if this sequence has a common ratio. If it does, that means that we have a geometric sequence. Remember, a common ratio is the number that each term is multiplied by in order to get the next term in the sequence. In order to find a common ratio, we need to take a term and divide it by the term that comes before it. So let's take a look at the first two terms in this sequence, -6 and 1. To find the ratio between these two terms, we need to take 1 and divide it by the term that comes before it, -6. When we take 1 divided by -6, we get -1/6. So here we're proposing that R, the common ratio, is -1/6. Now in order for this sequence to have a common ratio, we need to get this same value for R whenever we perform the similar division with any two other consecutive terms in this sequence. So let's take a look at the next set of consecutive terms, 1 and 8. We find the ratio between them by taking 8 and dividing it by the term that comes before it, 1. 8 divided by 1 is 8, so this value of R is 8. Is -1/6 equal to 8? No, it's not. Those two numbers are definitely not the same. Since we did not get the same value for R, that means we do not have a common ratio in this sequence. So the sequence is not geometric. But is it arithmetic? Well, let's see. A sequence that is arithmetic has what is called a common difference. So we need to check and see if our sequence has a common difference. Remember, a common difference is the constant amount of change between terms in a sequence. So here we need to see if that difference is the same for the consecutive terms. Again, take a look at the first two terms, -6 and 1. To find the difference between those two terms, we take 1 and subtract the term that comes before it, -6. 1 minus a -6 is 7. So here we're proposing that D, the common difference, is 7. But we need to check the other consecutive terms. So here we now look at 1 and 8. We find the difference. 8 minus 1 is 7. So we get that D equals 7. Hey, look! We got the same value for D each time. That means to go from -6 to 1, we need to add 7. To go from 1 to 8, we need to add 7. If this pattern continues throughout the entire sequence, that means that we have a common difference, and the sequence is arithmetic. That means in our next step, we need to check the rest of the terms in this sequence to see if they follow this similar pattern. Well, here we now have 8, and we need to get from 8 to 15. Well, if we take 8 plus 7, we get 15. And sure enough, if we take 15 plus 7, we get 22. We have this pattern of adding 7 each time we want to get the next term in the sequence. Since this is the same number we're adding each time, that means that we do indeed have a common difference. Since we have a common difference, that means that this sequence is arithmetic. Now let's take a look at our other given sequence. Here, we need to see if this sequence is arithmetic or geometric. Again, let's start by testing to see if it's geometric. That means that we need to see if we have a common ratio. If we do, that means that our sequence is geometric. So again, we look at the first two terms, 324 and 108. To find the ratio between them, we take 108 and divide it by the term that comes before it, 324. When we perform this division, we get 1/3. So here, we're proposing that R, the common ratio, is 1/3. But to check to make sure that we keep getting the same value for R, we need to check the next two consecutive terms, 108 and 36. We find the ratio by taking 36 divided by 108, and we get 1/3. So we're saying that r is 1/3. We have the same value for r. In order to get from 324 to 108, we need to multiply by 1/3. To get from 108 to 36, we need to multiply by 1/3. But does this pattern of multiplying by 1/3 to get the next term continue? Well, we need to check the rest of the terms in this sequence to make sure they follow this pattern. If they do, we have a common ratio. That means that our sequence is geometric. So let's look. Here, if we take 36 and multiply it by 1/3, we get 12. And if we take 12 and multiply it by 1/3, we indeed get 4. So that means our sequence holds this pattern of taking a term and multiplying it by 1/3 in order to get the next term in the sequence. That means that we have a common ratio of 1/3. And that also means that this sequence is geometric. Now, what happens if you get a case where your sequence does not have a common ratio or a common difference? In that case, you have a sequence that is neither geometric nor arithmetic. But here, we had two sequences. This sequence was arithmetic, and this sequence was geometric.